Hey y'all, in this video we are going over question 1 from the study guide, and for this set of questions we're going to be using this graph here. My number 1 tip is just to check what type of graph you're looking at, and in this case we're looking at a position graph. So on the test, always check what kind of graph you've got, right? So for question 1A, we're looking for what the velocity is from 0 to 5. On a position graph, you want to find velocity. And an easy way to help you remember what to do is if you put the list of our graphs. So we have position time graph, velocity time graph, and an acceleration time graph. This is a list of the graphs we learned. If you want to go down this list in this, and they have to be in this order, you're going to use slope to do that. And if you go up the list, which we don't care about right now, but you'll use area to go up the list. So if you're not sure, draw that out, and that will help you determine if you want to use slope or area. So here we want to use slope because we have a position and we want velocity. So for 0 to 5, we're going from 0 up to 10. So our rise is 10 meters. And then our run goes from 0 over to 5. So it'd be 5 seconds. Don't count the boxes here. One common mistake is counting over like one box, but one box is 5 wide. So just be careful not to count boxes, right? So back to the 10 over 5, that'll simplify into 2 meters per second. And that is your answer for 1A. Right. Moving on to B, what is the acceleration from 0 to 5? So this one here just kind of takes some thinking through. There's not actually any math going to be involved here. So you have a position graph and you want to know acceleration. To show acceleration on a position graph, you have to have a curved line of some sort, and we don't have a curved line here. We have a diagonal line. A diagonal line tells us that we have a constant velocity. If you have constant velocity, then you have no acceleration going on. So the answer to this question is 0. There is no acceleration going on. And if I gave you a curve, I've never taught you how to find the slope in that curve to then figure out eventually the acceleration. So you can't even do it if I gave it to you, which means I'm not going to give it to you. So if I ask you a question about acceleration on a position graph, the answer is going to have to be 0. Okay. All right, moving on to C, during which segment is the object not moving? So again, this is when it's important to look at what type of graph. So again, we're working with position graph, and you want to ask yourself, okay, what shows me not moving on a position graph? And that would be a horizontal line, right? So C is when we have the horizontal line, and that's when we're not moving, right? For D, what the displacement of the object is. So on a position graph, this is plotting where the object is located. For instance, at 0 seconds, it's at location 0. At 5, it's at 10 seconds. At 10, it's at -5, and so on down. So it's just telling you exactly where it is. If you think of this as kind of like a track or like a timeline, not a timeline, but like a number line. If this is spot 0 in the middle, then 10 would be over here, -10 way down here. So this person started here, they went to 10, they went down to -5, which I didn't mark, and then stayed there for a while, and then went back to 0, okay? So overall, the displacement is the difference from where they started, so in this case, they started at 0, and where they ended. And this case, they ended back at 0. So the displacement would be 0 meters, right? If I gave you a different time frame, in this case I just said what is the displacement, but if I said, okay, we're only going to pay attention to the first 10 seconds, we're going to look at the difference from where we started to where we are at 10 seconds, in which case would be -5 is the difference, all right? If it was 0 to 5, your displacement would be +10 because you're 10 away from where you started, okay? Then for E, when is the speed the greatest? This is when you're looking for the steepest line. It doesn't matter if it's positively sloping or negative sloping, because speed is just how fast, not the direction. So it can be a negative answer. Now in this case, it actually is, because B is the steepest. You can work this out mathematically by using slope to do it, but you can pretty much tell on these that like B is super steep compared to A and D. So you don't have to do the math, but you could do the slope for all 3 diagonals if you needed to reassure yourself. Right? All right, well, that is it for question 1. Let me know if you still need help with it.